There's an astronaut orbiting Earth right now who is literally aging slower than you are. And the terrifying part? When he lands, the difference will be measurable, provable, and it will have happened to every single person who has ever left this planet. Time. You feel it ticking every second of every day. But here's what nobody tells you in school. Time is not a constant. It bends, stretches, and warps depending on where you are and how fast you're moving. Einstein figured this out over a century ago, and scientists are still uncovering just how deeply strange the implications really are. Einstein's special theory of relativity, published in 1905, shattered the idea that time flows the same for everyone. He proved that the faster you move through space, the slower you move through time. This isn't philosophy, it's physics. It's been confirmed by atomic clocks, particle accelerators, and GPS satellites. Here's how mind-bending this is. If you boarded a spacecraft and traveled at 90% the speed of light for what felt like 5 years to you, you'd return to Earth to find that over 11 years had passed for everyone you left behind. Your friends would be older, your family would have aged, but you'd barely have changed. But speed isn't the only thing that warps time. Gravity does it too. The stronger the gravitational field pulling on you, the slower time moves for you. Stand at the base of a mountain, and time literally ticks slower for you than for someone standing at the summit. The difference is tiny, but it's real. It's been measured. In 1971, scientists loaded 4 cesium atomic clocks onto commercial airplanes and flew them around the world. When the planes landed, those clocks were compared to identical clocks that had stayed on the ground. The airborne clocks were off. Fractionally, impossibly, undeniably, they had ticked at a different rate. Time dilation wasn't just theoretical anymore, it had flown around the Earth. And here's something that should make you feel genuinely strange. Your GPS wouldn't work if engineers didn't account for time dilation every single day. The satellites orbiting Earth move so fast and sit in such weak gravity that their clocks run about 38 microseconds fast per day compared to clocks on the ground. Without a correction, your navigation would drift by nearly 7 miles every single day. But that's nothing compared to what happens near the most extreme gravitational objects in the universe. The next facts we're about to cover involve black holes, and what scientists have discovered about time near their edges will genuinely disturb you. If you could hover just above the event horizon of a black hole, the point of no return, time would slow to a near-complete crawl for you. An outside observer watching you through a powerful telescope would see you frozen, like a statue suspended in amber. You wouldn't feel anything unusual, but from their perspective, they could watch the entire future of the universe unfold before you moved a single inch. This phenomenon even has a name, gravitational time dilation, and it's been confirmed through real observation. In 2019, scientists captured the first ever image of a black hole in galaxy M87. The physics around that object matches Einstein's prediction so precisely that researchers were stunned. A man who died in 1955 had correctly described something 55 million light years away. Now here's a detail that Hollywood actually got right. Sort of. In the film Interstellar, characters land on a planet near a massive black hole called Gargantua. Every hour on that planet equals 7 years back on Earth. Scientists consulted on that film confirmed this is physically plausible. The forbidden truth about extreme time dilation is that the math genuinely allows for this. Plot twist. Time dilation doesn't just work in extreme outer space. It's happening to you right now, depending on which floor of your building you're on. Scientists have measured time running faster on higher floors than lower ones. The difference is roughly 90 billionths of a second over a lifetime. Tiny, but real. Your head is literally aging fractionally faster than your feet. If you're learning something genuinely mind-blowing here, hit that subscribe button. It's completely free, and we release new videos on the universe's greatest mysteries every week. And trust me, You do not want to miss what's coming in the second half, because the most unbelievable consequence of time dilation involves something that hasn't even happened yet. Here's something that should permanently change how you think about the universe: the twin paradox. Imagine two identical twins. One stays on Earth, the other boards a spacecraft, rockets away at near light speed, and returns. The traveling twin is younger, not metaphorically younger, biologically, molecularly, measurably younger. This isn't science fiction. The physics is unambiguous. But here's the part that breaks people's brains. From the traveling twin's perspective, wasn't it Earth that moved away and came back? Shouldn't the Earth twin be younger? The answer is no, and it comes down to something hidden in the math. The traveling twin undergoes acceleration and deceleration. That breaks the symmetry. There is a real absolute difference between them. And this isn't just theoretical. It's been observed in subatomic particles. Muons are particles created when cosmic rays slam into Earth's upper atmosphere. They decay so fast, they shouldn't even survive long enough to reach the ground. But they do. Because they're traveling at 98% the speed of light, time dilation extends their lifespan enough to make the journey. We literally see time dilation happening in nature every single day. What you're about to hear was only fully confirmed within the last decade. And it's the fact that has physicists genuinely questioning the nature of reality itself. It turns out that not only does time slow down near massive objects, the rate of that slowing is not smooth. It's quantized at the smallest scales in ways that suggest time itself may not be continuous. It may come in discrete chunks. The Planck time, 539 times 10 to the negative 44 seconds, is believed to be the smallest measurable unit of time that can physically exist. Below this threshold, our understanding of physics completely collapses. Time as we know it may simply cease to have meaning. It's the terrifying hard boundary of human knowledge. Beyond it, our equations return only silence. Here's the most mind-blowing implication of everything we've covered. Time travel to the future is not only possible, it's already happened. Astronaut Scott Kelly spent 340 days on the International Space Station and returned to Earth 8.6 milliseconds younger than he would have been had he stayed on the ground. He traveled 8.6 milliseconds into Earth's future. That's not a metaphor. That's measured, documented, real. And the secret implication that keeps physicists awake at night: if time travel to the future is confirmed real physics, then general relativity technically doesn't forbid closed time-like curves, paths through space-time that loop back on themselves. Time travel to the past may not be impossible. It may just require conditions so extreme they border on the unachievable. The door isn't closed. It's just extraordinarily heavy. So here's what we know for certain. Time is not a river flowing at the same speed for everyone. It is a fabric, warped by mass, stretched by speed, quantized at the smallest scales, and already proven to run differently for every single person on this planet. You are not experiencing the same time as anyone else. You never have been. The universe is far stranger than it appears. If time dilation shook you, wait until you hear about the invisible forces that make up 95% of everything that exists. Our next video reveals the hidden truth about dark matter and dark energy, the two most mysterious substances in the cosmos that scientists can't see, can't touch, but know are holding the entire universe together right now. Subscribe and click the next video, because what we don't know about reality is even more terrifying than what we do.